Hi, good morning. Welcome to my science class. Let's have a short review about our previous lesson. What is hydrocarbons? Hydrocarbons contain only carbon and hydrogen. What are the two types of hydrocarbons? We have saturated hydrocarbons and unsaturated hydrocarbons. For today's topic, we will be focusing about alkanes, a type of saturated hydrocarbons. For today's lesson objectives, we will be able to identify the process of nomenclature and molecular formula of alkanes, demonstrate the structural and condensed formula of alkanes, value and share the uses of alkanes. What is your favorite fruit? Mine is apple. It may reduce the risk of stroke, control obesity, it has anti-cancer benefits, a lots of vitamin C, a dietary fiber with iron, calcium, B complex vitamins, and reduce the risk of asthma. What can you say about the skin of an apple? What did you notice while washing the apple about its texture and appearance? The solid alkanes that make up waxy coatings on fruits and vegetables like apple help retain moisture, inhibit mold, and enhance appearance. Okay, let's play a game. Guess the word. Guess or think of 6-letter words that can be extracted from the word alkanes. I prepare some clue for you. The answer is uncles. Did you get it right? Next. How about a 5-letter words that can be extracted from the word alkanes? Here are some clues. The answer is snakes. Next. Michael Jackson is doing his famous dance moves. The answer is leans. Focus on the upper portion. It also part of our nose. Nasal. Tom is acting strange, like he is hiding something. The answer is snake. Here are some possible answers. We have lanes, leaks, and lakes. Thank you for your participation. Now, let's move on to our topic. What is alkanes? Alkanes made up of only carbon and hydrogen atoms. It also called paraffins. It has a single bond between carbon atoms and has a general formula of CnH2n plus 2. And the names of alkanes usually ends in A and E. Remember that carbon is the only element that can form so many different compounds because carbon has 4 valence electrons. It means that it can form 4 chemical bonds to other atoms. It is also the reason why it has its own field in chemistry. It's called organic chemistry. It is the studies of compounds in which carbon is the central element. The properties of carbon make it the backbone of the organic molecules which form a living matter. Naming hydrocarbons, these prefixes must memorize. Yes, you have to remember and memorize it all. The 10 prefixes here has corresponding carbon atom number. For met, 1 carbon. For eth, 2. Prop, 3. But, 4. Pent, 5. Hex, 6. Hep, 7. Oct, 8. Non, 9. And dec, 10. What is molecular formula? A chemical formula that gives the total number of atoms of each element in each molecule of a substance. For example, water. The molecular formula of water is H2O. It means it has 2 hydrogen atoms and 1 oxygen atom. Identify the name and formula of alkanes. In the table, we have met. Met has 1 carbon atom only, plus A and E, so it will form methane. For the molecular formula of methane, since met has 1 carbon atom only, deriving from the general formula CnH2n plus 2, N indicates the number of carbon atom number. So we have here C equals 1 for the carbon. And for the hydrogen, H, 2 times 1 plus 2 is 4. So we have molecular formula of methane, which is CH4. 1 carbon atom and 4 hydrogen atom. Next. Okay, we have here oc plus A and E, it will form octane. Since oc has 8 carbon atoms, so we have C equals 8, and for hydrogen, 2 times 8 plus 2 is 18. So the molecular formula of octane is C8H18. It means it has 8 carbon atoms and 18 hydrogen atoms. Did you get it right? For your individual activity, counting carbon and hydrogen, fill up and answer to complete the table. Do this in your notebook as your seat work. Okay. You will be working on alkane number 2, 3, 4, 5, 6, 7, 9, and 10. Good luck! And here are the answer of your activity. So we have methane, CH4, ethane, C2H6, propane, C3H8, butane, C4H10, pentane, C5H12, hexane, C6H14, heftane, C7H16, octane, C8H18, nonane, C9H20, and the last, decane, C10H22. Here are some sources of methane. 31% came from natural gas and petroleum system. 25% from enteric fermentation. 18% landfills and manure management. 9% coal mining, and the other 7%. What do you mean by enteric fermentation? Enteric fermentation is a fermentation that takes place in the digestive system of animals. Those animals is called ruminant animals. They have a large forestomach, within which microbial fermentation breaks down food into soluble products that can be utilized by the animal. Usually, methane is exhaled or belched by the animal. So, the cow burps add to the global warming. Next, are you familiar with this gas stove? It's made of propane and this butane gas. It is used for cooking. Now, we are ready to demonstrate the structural and condensed formula of alkanes. What is a structural formula? It indicates the bonding arrangement of atoms in the molecule. Here we have the molecular formula of water, which is H2O, and at the left side, its structural formula. It consists of symbols for the atoms connected by short lines that represent chemical bonds. 1, 2, or 3 lines standing for single, double, or triple bonds. In the case of water, it has a single bond because it has one line connecting two hydrogens to one oxygen. Sometimes, structural formula is called skeletal formula. Why do you think so? Okay, for you to understand the structural formula, here we have the structural formula of water. The central atom, as you can see, it is the oxygen. And the attached atom is the hydrogen. Another example of structural formula. Are you familiar with acetone? What are the uses of acetone? In the structural formula of acetone, we have the central atom, carbon. How many carbon did you see? And how many hydrogens attached to the carbons? Do we have oxygen in the structural formula of acetone? Yes. How many bonds did you notice in the structural formula of acetone? As you can see, we have one single line and one double lines. It means it has a single bond and double bond. Next, the condensed formula. It is the bonds to each carbon are omitted, but each distinct structural unit is written with subscript numbers designating multiple substituents, including hydrogens. Shorthand line formulas omit the symbol of carbon and hydrogen entirely. Okay. The molecular formula and the condensed formula of water is just the same because it is very short. And you should remember that the molecular formula should match the number of atoms per element in the condensed formula, as well as the number of the atoms in the structural formula. Okay, for example, are you familiar with ethanol? It is commonly used medical alcohol. It's called ethyl alcohol. Alcohols in various forms are used within medicine as an antiseptic, disinfectant, and antidote. Here is the molecular formula of ethanol. We have C2H6O. And at the bottom, the structural formula of ethanol. As you can see, the molecular formula matches the structural formula. We have 2 carbon atoms as well as in the structural formula. We have 6 hydrogens, 1, 2, 3, 4, 5, 6, and 1 oxygen. Now, for the condensed formula of ethanol, remember that the central atom of structural formula is in the middle, and the attached atoms usually in the outer. So in the case of ethanol, we have 2 central atoms, the carbon and the oxygen, while the attached atom are the hydrogens. Take a closer look at the structural formula of ethanol. The technique for writing the condensed formula of ethanol is to chop it one by one to its central atom. As you can see, we have the first carbon atom here and 3 hydrogen attaches to it. So we'll just have to write 3 as a subscript. For the second central atom, which is also the carbon, how many hydrogen attached to it? We have 2. So CH2. And the last central atom is oxygen. How many hydrogen attached to it? 1. So CH3 and CH2OH is the condensed formula of ethanol. And that is how we write the condensed formula deriving from the structural formula. Remember the technique. You just have to chop it one by one to its central atom and count the number of the hydrogen atoms attached to it. Okay, this is my example for methane. As you can see, the structural formula of methane matches the number of molecular formula per atom. So we have 1 carbon atom and 4 hydrogen. 1, 2, 3, 4. And also for condensed formula, it's just the same of molecular formula because it is too short. As you can see in the diagram, the 4 dots around the carbon represent the 4 valence electron. And for the hydrogen, it has 1 dot because hydrogen has 1 valence electron. This is how methane formed. This 1 dot belongs to hydrogen and the other one belongs to carbon. And it will form a single bond or a single line like in the structural formula. Another example for octane. As you can see, the molecular formula of octane is C8H18 and it matches the structural formula. How many carbon atoms in the structural formula? 1, 2, 3, 4, 5, 6, 7, 8. C8. And how many hydrogen atoms around it? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Now, as I've said earlier, the technique for writing the condensed formula is to chop it one by one according to its central atom. So the first carbon, we have 3 hydrogen. 1, 2, 3. And for the second carbon atom or the second central atom, we do have 2 hydrogens. And the third, up to the 7, we have 2 hydrogens. And the last one, or the 8th carbon atom, how many hydrogens attached? 3. Okay, so that is how we write the condensed formula. Did you get it? Remember that alkanes is a homologous series. It means it shares similar chemical properties under the same general formula and it reacts in a similar way. Study the graph. So as you can see, it is the relationship of the boiling points of alkanes to the number of carbon atoms and to the temperature. Question number 1. What is the relationship of number of carbon atoms to the boiling points of alkanes? Okay, what is your answer? As the number of carbon atom increases, the boiling point also increases. It is directly proportional. Number 2. How would you relate the number of carbon atoms to alkanes of being gas and liquid state? The answer is the first 5 carbon atoms are in gaseous state, while the higher number of carbon atoms are in liquid phase. As the number of carbon increases, the more stable it is. Differentiate alkanes in gas state to its liquid state regarding to the boiling points. The answer is the gaseous state of alkane have lower boiling points, while the liquid alkanes have higher boiling points. The more stable the alkanes, the higher the boiling points. Okay, are you ready for your group activity? Each group must write the condensed and structural formula to manila paper as output of your group. Copy the format table in my recent discussion. Okay, this is how I'm going to assess or grade your performance. For group 1, you have to report your output through peer teaching skit. Group 2, make jingle to present your output. Group 3, make sequential pictures clips to present your output. And last, group 4, create a newscasting skit to present your output. Okay, and those are the correct answer of condensed structure formula of the remaining alkanes. Here is the structural formula of the rest of the alkanes. You have pentane, 1, 2, 3, 4, 5. Hexane, 1, 2, 3, 4, 5, 6. Heptane, 1, 2, 3, 4, 5, 6, 7. Octane, 1, 2, 3, 4, 5, 6, 7, 8. And nonane, 1, 2, 3, 4, 5, 6, 7, 8, 9. Decane, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Read and analyze each slide and write a short essay about the importance of alkanes. and share to the class your write-up. Here are some application and uses of alkanes. Please read and analyze. Here are some products containing alkanes. Another uses of alkanes. Okay, to wrap up our lesson for today, please answer the following. What is alkanes and its general formula? How does the naming of alkanes related to the number of carbons? How do you write the structural and condensed formula of alkanes? Give some of the common uses of alkanes. Now, you are ready for some quiz. Read each question or statement carefully. Choose the letter of the correct answer. Number 1. Which among the following alkane has the least number of carbon atoms? A. Pentane, B. Methane, C. Ethane, D. Octane. Number 2. Which of the following alkane has the highest number of carbon atoms? A. Pentane, B. Methane, C. Ethane, D. Octane. Number 3. What is the molecular formula of pentane? A. C5H14, B. C5H12, C. C6H12, D. C6H14. Next, number 4. What is the molecular formula of decane? A. C10H22, B. C10H20, C. C9H20, D. C9H22. And for the last number, name this alkane. A. Heptane, B. Hexane, C. Nonane, or D. Octane. Are you finished? Okay, let's check your work. The correct answer for number 1 is letter B. For number 2, letter D. For number 3, B. Number 4, and number 5, letter A. Did you get it all right? Now, for your another enrichment activity, study the disadvantages of abusing the uses of alkanes, how it affects our environment and economy. Type your answer in Microsoft Office Word and print it for you to present to the whole class for our next meeting. This will serve as your assignment. Thank you very much. See you in our next meeting.